Hi, welcome to part 4 of the introduction to Synte, the synthesis-based live coding environment and language. So today I want to try and do something a bit more fun, and gonna try and make a little basic house beat, and along the way try and demonstrate a few features. So if you just kind of start typing stuff into Synte, there's no real, there's a temptation for it to be a kind of a bit of a jumble, different stuff. But there are ways that you can make things kind of synchronize. I've left it as a kind of design decision, as an option, rather than it's fixed, because I feel like, well, it's nice to have options, basically. So let's start off with, we're going to define a tempo, and then from that tempo, so that's 12 BPM, that's beats per minute, so that's the frequency of each beat. So if we now want to define a grid, which I'll explain a little bit more in a sec, but if we multiply that BPM by 4, then we should get 16 grid points in a bar, because we've done 4 beats times 4. And then we can do oh, I've forgotten what, let me just check. So let's do this shell autocomplete never works when you want it to. So I'm just going to call up a list of all the functions here, because I can't remember. Yeah. So I've got a function here called grid, which is basically a very simple ramp wave followed by a comparator, which is less than. So what that means in everyday kind of speak is that as the ramp, the output of the ramp is below 0.5, the output of less than is going to be 1, and when it crosses 0.5 it's going to go to 0. So what you end up with is a pulse wave, which is exactly half what's known as the duty cycle, which is just like how wide the pulse wave is from the 1 part to the 0 part. So and then that gets sent out to the grid. So I'm going to use that. I mean, I don't have to use that, but it's just a kind of, so if I type grid, that's now going to send out a signal to grid. Now both tempo and grid signals are special built-in exported signals, which means that every running listing can access those and modify them. If you modify them in a listing, all subsequent listings will see that value. If it gets modified again, that will kind of overwrite the previous value. So you can have 2 different grids, from 0 to 5 index of listings. You could have 1 grid, and then you could update it to a different value and have them on a different grid. Now, from that grid, which has gone from being a tempo, which is a form of frequency, is now the output of that grid in the listing is actually a square wave. So what we're going to do is count that using a function called count, and we're going to count 16 of them. I can just quickly show you count in this window. So now that looks a bit like gobbledygook, but it's essentially similar to a ramp oscillator, except it's also kind of detecting the kind of edge of the square wave. You might notice that it goes plus A mod out A, which is basically a ramp, but each time it's not adding a frequency, it's adding the actual number 1. So the output of count is going to be a number between 1 and 16. So now what I'm going to do is subtract a number. Could be any number in theory, this, but I'm going to subtract 8. So that's important because the next operator I'm going to use is sync. And what this does, because there's a dot in the beginning, it's going to finalize the listing, and when I press enter return, it's going to send it off to the sound engine. And it's also, that last instruction is also going to send a sync pulse, which again can be accessed by every listing. Now this isn't just a normal kind of exported signal, it's kind of more built in, so to make it more kind of, well, that's how I've implemented it for now, but I mean, I'm not sure if it could be just a standard exported signal, but we'll see. I'm going to fire that off now. Now that's not going to make a sound because it's not sending anything to the output. It's not really generating anything except these kind of relatively slow grids and waves and stuff. But however, what we can do is on the next one, now we've got a tempo we can access. So everything will be to the same tempo. And then we can use a POSC, which is a synced oscillator object. Now, so I've done POSC 0. 0 is the phase offset of that object, and it's similar to a normal ramp wave, except that it can it synchronizes to the sync signal, and it synchronizes with an offset given by the operand, which is 0, so it'll be an offset of 0. Now that's a ramp wave. I'm going to do something here, which is multiply it by 8, clip 0, and flip it. Now that's not going to be immediately intuitively obvious what that is exactly doing, but I'm shaping that ramp wave into a short kind of ramp down. The flip one is the most important one because I've flipped it from a ramp upside down, so it's now a kind of descending thing. So now I can use that as a envelope. So if I next type noise and mix, then what you should hear is that kind of really simple hi-hat on each beat of the bar. Now what I actually want to do is edit that because so I've just brought up the listing, which is a new thing I've added, where each running listing will be saved as a file which you can then edit and reload. It's a bit of a kind of hack around, kind of like workaround for the fact I've not got a proper like text-based interface. But at the moment, I don't really want to be spending a lot of time learning libraries and integrating them into this and building user interfaces. At the moment, the user interface is the terminal, and that just means I can focus on the sound engine and the language and the kind of design implementation of like the actual synthesis and everything. So now I'm going to reload that listing. You might have heard briefly sounded like two hi-hats were close together because it's flipped out of phase. And the reason I've done that is so I can then do a kick which is in phase. So every time I type out a kick, I always comes out slightly differently. I've made some really nice ones in the past, but I never seem to be able to summon them up on demand. But what's great is that I'm constantly exploring different ways of making kicks. So I'm actually going to do a slightly longer kick. So that mull4 factor, the lower the number is, the longer the kick will be. And that's essentially a fraction of like 1/4 of one beat is the length of the envelope. Now I'm going to go for very simple sine-based kick, and I'm going to just add a touch of distortion on it so it makes it more audible if you're not listening on kind of wide range speakers. Now let's see if this is going to work. So there we go, we've got like the rudimentary skeleton of like a very basic house beat. But I'm going to mute that kick for now. I'm going to show you what you can use the grid for. So at the moment, Synte's got this built-in Euclid function, which is for making Euclidean rhythms. But now I've added the grid exported variable, and you can actually kind of do it between listings. That makes any sense at all. But so I'll show you what I mean by that. So we're going to go in tempo, and then we're going to divide by 4. So now we've got the frequency of 1 bar, and then let's say we'll times it by 3. That asterisk is an alias like equivalent to mull. And then we're going to do another synchronized oscillator, and then we're going to convert it to a square wave, and then we're going to sample and hold it using the grid. Now as I type this out under the pressure of doing a video, I might get this not quite right, but now we should have some kind of Euclidean rhythm, but the output is going to be like a square wave, which is just a flat envelope, which is a little bit boring. So I'm going to use this Dirac function, and then this down shaper, which kind of creates a ramp out of the Dirac pulse, which is just, it's converted the square wave into a series of like really short pulses. And what frequency? I'm just gonna make that a 100 millisecond long envelope. So I'm not going to do the mental arithmetic in my head, but there's all kinds of different ways you can specify like times and stuff, but we'll stick with that for now. And then if we do noise and mix, so you can hear that's kind of not it's not a regular rhythm in the sense that it's not on every beat or on every offbeat. So if we just solo 3, and then let's bring in the kick. And we'll bring in the hi-hat. So while this isn't the most beautiful house beat of all time, it gives you an idea of what you can do with it. Let me see. I don't really like that, so I'm going to try and edit the last one I did. Let's try giving it a phase offset. So let's reload 3. Still don't like that. Let's give it a longer time, and also let's play around. This is something cool we can do. So if I type in mouse Y, I'm going to now use the value of the Y axis of the laptop mouse to control what the offset of that pulse, the first pulse wave in listing 3 is. So that's while it's not kind of more, it's a little bit more rhythmical and musical to my ears, that. So let me just pause that for a second, because that's going to get a little bit boring. Well, while I'm like talking over it, let's take it up a notch. So I'm going to do in pitch, and then I'm going to do another function, one I prepared earlier, a while ago actually. So this one, there's quite a lot of stuff going on in this, but essentially you feed it a pitch and it outputs 3 sine waves that are at frequencies of approximately part of a major 7th chord. Anyone who knows music theory might be screaming at me that is actually just a major chord, but I think that 1.875 is the 7th. So actually I think it's 4 notes in the thing. That makes a bit more sense. So I'm going to do major 7th, and then I'm going to just send that off. Now that's not making any sound. Well, let's give it a pitch. 440, which is an A. Not sure which octave that is, but it is an A. And then we'll send that out pitch. And then we're just going to end that. That's not working. Done something wrong here. Yeah, I'm not sure what exactly I've done there. But I'll have to go and triage. Oh, I know what I've done there. Let's edit. I typed in a ridiculously high frequency. Yeah. Well, that is not the best combination of chords, but I actually prefer the lower pitched version, so I'm gonna go to change that to now. We notice that the listing 5 is let's delete 6 because I don't want that. It's still sending pitch information even though it's muted, because only the output of the listing is muted. That would normally go to the sound card. So let's bring in some now you can hear a little bit of pumping in the audio. I think I've been fiddling with the limiter settings, and it's just a little bit overcooked. But let's set a longer release time. In fact, I'm going to go for this video is getting quite long, but I'm just going to quickly shape that major 7th chord with a VCA. So I'm going to do that by creating a VCA first in tempo, and then let's just keep it simple and one beat per bar, one note on each beat, 4 per bar. I'm going to use this exp function, which I want to kind of change in future, but essentially it's changes a linear slope into more of an exponential one. from the higher the number, like more rapid the slope, and also it defines what a zero value is. I won't go into too much detail on that for now because I'll just go off on a tangent. Now what I'm going to do is actually low pass filter that just to make it a little less clicky. And this is one of the fun things you can do with Synte that you can do with things like modular synths, but a lot of normal or kind of typical synths and software synths, you can't actually do filtering on LFOs and envelopes and stuff. And I discovered the other day that you can make some really nice kicks using a combination of low pass and high pass filtering on a square wave or a pulse wave. Might go into that more depth in a future video if you want a bit more of a kind of deep dive into the world of bass drums. Okay, so I'm going to now send that out to a VCA signal, and I'm also going to take in the output of listing 4 using the from operator, and I'm going to multiply that by our VCA. Oops. And then I'm going to, because it's already been mixed in 4, I'm just going to send it straight out to the DAC using out DAC, which is contained within the mix function. Don't worry if you can't follow all of this. The main thing is to kind of like try and build up a picture of the different possibilities and things going on with Synte, and I'll probably go over all this stuff in later videos in more detail, or more kind of make it a little bit more kind of break it down a little bit, because it's not that complicated. It's just when you haven't heard it all before, it can seem a bit daunting, like what the hell's going on here. So you might hear a slight change there. I'm going to now mute 4. Now let's just solo 7. Now it's quite quiet 7, so what I'm going to do is use the mouse. Actually, before I do that, let's just I'm going to edit because previously used a mouse, but I think we settled on a good value of 0.35, so I'm going to just put that in so that's kind of setting that mouse value for that one. And now what I'm going to do is I'm going to turn up the level of 4 because it sounds a bit quiet at the moment. I've obviously turned it down, but now as I bring up the value of mouse Y, that's brought it up a little bit. So now I'm going to bring in our hi-hats. Oh, I need to reload the I think that'll do. That's just made it a bit more. I did tweak the mix function recently in relation to the noise and low frequencies in particular. I think I might have to revisit that. I mean, it's hard to get it completely right for everything because it is just based on very simple heuristics. So now, as one final thing, if we do in tempo and then divide by 2. So now I've got, oh no, let's divide by, let's divide by 8. So now we've got 2 bars, frequency of 2 bars worth. And then I'm going to do a pulse. Now I've not synchronized this one because our synchronizing value at the moment is once per bar. So because this is over 2 bar, you'll only ever hear the first bar of it. And then I'm going to just filter that just to round it off a little bit. I'm going to add, I'm going to do, I'm just kind of tweaking the values a little bit here, and then I'm going to send it out. To the pitch. So now with overriding that pitch value coming from listing 5, which I might just delete that just for clarity. But we could also do something like let's just kind of try and jam it up a little bit. Now I won't explain this one because the video's already gone on quite long, but I'll probably do the next video about defining scales. Let's see how this is going to work. So that's a little bit more interesting. I'm going to leave it at that for this video. Hopefully that's built up a little bit of more picture of the kind of more kind of musical potential of this program. So let's give it a fade out. 30 seconds. Right, I'll see you in the next one.